Yes, Professor McQueen, another great answer. I've got a question from myself
Okay.
because I've noticed a lot of the critics, they look to a book titled, and I'm not too sure if you're familiar with it, but it is The Grand Canyon Monument to an Ancient Earth. And it looks like one of their main objections to our position on the flood in
Yes.
that book, that I frequently see the uniformitarians source and present. They'll say the condition and distribution of fossils in the strata do not reflect the rapid burial of sea animals and small land animals out of deep turbulent water. This seems to be one of their main objections. I'd be curious how you would feel is the best way to respond for that.
Yeah. Let me use the notepad that I am trying to keep track of time. By the way, how long have we gone so far? Just so I can. Okay, we're up to an hour now. Can we keep on going? An hour?
Oh yeah, yep.
Okay,
of course.
good. Okay, so let me use my notepad here, and I'm going to write 3 fossils down. I'm going to write the amphibian footprints that are found at the top of the Grand Canyon, and I'm going to write the red wall limestone, and then at the bottom, I'm going to put a T, and then the angular unconformity. And now let me put this close to the screen. All of you take out a sheet of paper and write down A and a line and R and T, and then that angular unconformity. The A stands for the amphibians in the Coconino sandstone. The R stands for the red wall limestone, and the T stands for the trilobites in the Tapete sandstone. So this is amphibian. This is a limestone, LST, and this is a trilobite, TIROLIB, and so forth. So there you go. You've got the amphibians, you've got a limestone layer, and the trilobites in the Tapete sandstone. Now, I am obviously leaving out some stratigraphic units for simplicity. Here's the stratigraphic section of the Grand Canyon. And when you look at it, I've left out some of the sandstones and the shales and other rock units, but I want to try to explain things simply. And so here, standing for truth, is the simple answer to it. For the last 40 years, flood geologists have concluded that what we're seeing with fossils is the burial of ecologic zones. Give you an example. I live in Louisiana, and in Louisiana, we have alligators in many of the water bodies that we call bayous, which is kind of a swampy area. I do not choose to live near an alligator habitat. Nobody I know, other than 1 or 2 of my buddies who actually receive special permits to hunt alligators, even go near alligators. We avoid them. Why? Because they will eat you alive. So nobody wants to live next door to a person or an animal that will cannibalize you. It's one thing to be shot, but it's a different level of being scared to be eaten alive. You see what I'm saying, George?
Oh, yeah.
Okay, so why don't we find human fossils with the trilobites? Well, the humans did not live at the depth in the pre-flood ocean, what I call Noah's Ocean. Imagine you got one world continent. I'll use my Play-Doh again here. Imagine you've got one world continent, and that's going to break up during the flood, but all around the outside, those are the beaches of the pre-flood world. Probably there was an indention so that if looked at from space, the one world continent looked like a C. We teach the children it stands for creation. And so the words Gondwana land and so forth are used for this. But there was a beach all around it. Most people in our modern world live within 100 miles of some sort of water. And if they live in Brazil, they're near the Atlantic Ocean. If they live in Peru or in Southern California, they like to be near the Pacific Ocean. So we would expect that pre-flood humans, of which there may have been a billion, other creation scientists say 100 million people could be alive from creation to the time of the flood. That's a huge number of people. Why don't we routinely find human fossils mixed in with these trilobites or amphibians and so forth? The explanation is ecological zonation. Dinosaurs, by the time of the flood, were very large animals. Let's not even argue as to whether they were herbivores or carnivores. If they stepped on you, you would be killed. So nobody wanted to live around these wild animals. And so it's no surprise that we don't find human fossils ordinarily mixed in with dinosaur or trilobite or amphibian. So the counter argument standing for truth is that when you look at the Grand Canyon, you find amphibian footprints, but the amphibians themselves were washed away. Whatever humans might have been nearby were washed away. Then you go down through the Grand Wall, the Red Wall limestone, which I would argue directly precipitated from the flood ocean. And then you go down to the base of the canyon where the Tapete sandstone is on this angular unconformity, and that probably marks the beginning of the Great Flood. And so you find creatures like trilobite that live not only in the ocean, but live on the bottom of the ocean. So the counter argument to that critique of flood geology is ecological zonation.
Well, that was a really great answer, Professor McQueen. I really like that, burial by ecosystems and habitats. I've even seen, and I've read Dr. Andrew Snelling point out that in the Bible, the land of Eden, we are told that a river flows out of Eden.
Yes.
And because we know that rivers flow downhill, and Eden would have been at a higher elevation, Professor McQueen, then we know certain animals like dinosaurs, certain dinosaurs like you were talking about, they may have lived in swampy lowland areas. And so various animals of different ecosystems and habitats, they would have been separated from man. So it makes sense that we wouldn't really find them together.
That's correct. And
so I think that's a great answer.
Well, we can follow up on that. What animals were Adam and Eve exposed to in the Garden of Eden? And the answer is, what do we know from Scripture, George? Adam named them all. And so every kind of animal, dinosaur, cow, snake, and so forth, was named by Adam. So he certainly was in contact with lions and tigers and dinosaurs and alligators. But what's the kicker in that, as we say? What's the rub? Well, the rub is this. Before the fall of mankind, these animals were vegetarians. These animals were part of the background of the Garden of Eden. The rivers that flow from Eden are a very important area for study for me because of the mineral resources, the placer gold and the onyx that we're told was found in those rivers. So, but back to your point, standing for truth, it's very true what Dr. Snelling says, that these ecological zones after the fall, as you get up to the time of, when you go from Adam to his descendants, we've commented about Methuselah and the fact that he lived 969 years. When you get up to the ages of these patriarchs, as they're called, and here's a good homework assignment for you. Go back to Genesis 5, 10, and parts of 11, realizing that Adam was living at the same time Methuselah was for part of his life. Now, these numbers, the 969 years that you have for Methuselah and the years that you have for Adam and Seth and so forth, these are overlapping years. So you got to be careful when you do your math. But the summary that you can realize is that as the years went on, thinking people were not going to build their homes in the ecology of alligators, in the ecology of dinosaurs or lions and tigers. Dogs and cats have been domesticated since the Garden of Eden. And so dogs and cats are always going to be found around humans because of the comfort they bring as pets. But otherwise, we've got ecological zones which help us to explain why we don't routinely find humans with dinosaurs and why we don't routinely find humans with alligators. Now, let me rush to an important point, George. In the book of Genesis, it's clear that Adam and Eve and their immediate environment there in the garden were around dinosaurs. And so when I'm asked the question, well, as a geologist trained in paleontology, how do you know that humans and dinosaurs coexisted? Well, because it's true, because the Bible tells me so. Because the Bible can be a trusted historical document. I know that humans and dinosaurs coexisted and were alive and well in the Garden of Eden. Does that answer the question, my friend?
Well, there was further evidence of dinosaurs living with man, because we see paintings on walls in caves. We see artifacts, clay pots and statues and carvings, etc. So there's other evidence to suggest that dinosaurs lived with man as well.
Ms. McQueen has been listening to our discussion, and she brought me this replica.
Oh, that's awesome.
Of what's called a ICA, it's Ica stone.
Ica stone, yeah.
From Peru. In 1997, on an expedition with John Patton and another man whose name will come in a minute here, Dennis Swift, thank you. And this is a replica of a rock from Peru. Got to be careful not to drop it on my top here. But you can see it depicts a South American descendant of Shem, Ham, and Japheth fighting with what appears to be T-Rex there. And so this provides archaeological evidence. Why would this be important? The reason it's important is the details of what T-Rex looked like known to Western science until probably the 18 and maybe even the 1900s. And so this constitutes archaeological evidence of the coexistence of man and dinosaur in the area south of Lima, Peru, called the Paracas Peninsula. Thank you, McQueen, for bringing me that. Okay, here we go. Hans has a question. Professor McQueen explored the Indian dwelling in the Grand Canyon walls. Hans, the answer to that is no. I was assigned by Dr. Gish, Dr. Alden, and others that were more senior than me to teach the philology of the canyon. Ever was at the right time to study the Indian dwellings. But I will comment that because of my interest in archaeology, those Indians, Native Americans, were descendants of Shem, Ham, and Japheth that moved from the Tower of Babel and the dispersion of languages to this part of the Grand Canyon. Okay, I see another question from Lena. The stair-stepped appearance of the erosion of the sedimentary rocks in the Grand Canyon, with sandstones and limestones forming cliffs and shales as gentle slopes, cannot happen if all these rocks were deposited in less than a year. Now, this is an interesting argument, Lena, that I have heard other people make, and I'll use this picture here as a way of answering your question. Let me get this, try to get the reflection moved from, well, let me turn the page here. It's got a piece of plastic on it. This is a tour guidebook that's been used for over 30 years with modification from the tours that ICR led in the old days to the Grand Canyon. And if you look at this cross-section of the canyon, it's a nice three-dimensional view that shows a black lava overflowing the canyon, but it shows just the question that Lena's asking. There's a stair-step design as you go up the canyon. The red wall limestone forms a cliff and so forth. How could you explain that within flood geology? Well, notice that the title of this book is Monument to Catastrophe. If we think about the formation of sedimentary rocks in a catastrophic view, Lena, it changes the dynamic. And so to begin with, you've got the Grand Canyon and all its rocks being laid down in this way, layer after layer. And then you have the erosion of the canyon by this spillover model. And so I will tear the Play-Doh into two pieces and move them close together. And now let's get the same view as you would from space. Let's turn it over here, and I'll move the two near my dark vest here so there's a space in between. Okay, that tear was produced by the catastrophic erosion of Lake Hopi northeast of the Grand Canyon. And as it eroded down through the canyon. And let's focus on that stair-step design. And let me try to make a stair-step here with my Play-Doh. So if I hold it like this, I hope you can see, I need to move it to the other side and up a bit. I hope you can see there's a stair-step right there. Well, the red wall limestone, its rock mechanics, its density, its compressive strength, its Young's modulus, all these different words from rock mechanics, shows that it's going to resist the erosion more than the sandstones and shales. And so not interbedded, but beneath the red wall limestone are some clastics, to use that word, they would more easily erode than the limestone. So I think within a catastrophic model, we have an even better way to explain those stair steps that you refer to.
Well, that's another great answer, Professor McQueen. I mean, these are some of the most common objections from the critics, and some of the objections you'll find in that book that I often see cited, titled "The Grand Canyon Monument to an Ancient Earth."
Yeah, I actually do not have that on my shelf. I've got some. Now, is this what they call a coffee table book that's maybe 14 inches long and 12 inches wide?
yeah, I believe it is.
Yeah, I may actually have that. Tell me the name of it again.
It's titled, and BioLogos promotes it. It's titled "The Grand Canyon Monument to an Ancient Earth."
Okay,
And
Grand Canyon Monument to Ancient Earth.
yeah, Monument to an Ancient Earth.
Before I come on again, I will look and see if that's the name. Years ago, I had a friend, he's passed away now, named Harry Stone, and ironically, Mr. Stone was a geologist. Why not? And he gave me as a gift this, he used to run a bookstore, and he gave me as a gift this big book. I'll see if that's it.
Well,
okay, next question.
Well, I guess from myself, it seems like they make the case, and I don't know why this would fit into their model, because I feel like this example is best explained by rapid burial, but maybe I'm wrong. They seem to point out that the existence of fossilized footprints and foot tracks, they seem to say that that's contradictory to the flood model and more consistent with the uniformitarian model. How can that be possible, these preserved footprints? Would that be more consistent with our model or their model, Professor McQueen?
Okay, let me reach over and get a binder clip. At least that's what we call these things in the U.S. I don't know what they're called elsewhere in the world. But again, I'll make my soft sediment. And let's say that we're 3 months into the flood, and one of these worldwide movements of catastrophic water brings sand from who knows where. The sand could be transported from east of the Mississippi River, or maybe it was transported from one of the maritime provinces of Canada. Who knows where the sand came from? So it goes across the North American continent, and you've got the floodwater above it. It's being deposited, and the amphibians have been able to escape to mountaintops long enough. And so imagine this to be an amphibian foot. They step into this probably carbonate-rich mud. You see the footprint they made there. In our model, another layer of sand comes over it so quickly that it washes away the creature but preserves the footprint. Now, the best example that I can give, many times we've lived in Louisiana now more than 30 years, and we've taken our children and some of our grandchildren to the beach, and we follow the little ones as they walk along the beach and make footprints. What's the observation there, George, when you've gone to the beach over the years? Do the footprints last more than one or two waves, or are they washed away? George has got his mic muted, so I'll let you answer, Standing for Truth.
Oh, sorry. I said you can see it before your eyes. It disappears within minutes.
Exactly. It disappears within minutes. So remember that the evolutionary community is trying to tell me, as a grandfather who's been around, I haven't been tricked maybe the first time, but I'm not tricked the second time. These people are trying to tell me, going back to my first contact with this 50 years ago, that the Coconino Sandstone is a beach which moved across northern Arizona. And yet when I look at the coconino sandstone, it's got knife edge contacts. It's got fossil footprints in it, which appear to be going up sand dunes. It's an unbelievable argument, George, because common sense tells
Right.
every grandpa and every dad that's walked with their children and grandchildren on the beach, it's gone before your eyes.
And oftentimes in the record, the fossil record, don't you find the footprints before you find the actual creature, right? As if they're running from the catastrophic floodwaters.
Yeah. Now, there are some places, some very unique places, such as the dinosaur footprints that are found south of Fort Worth, Texas, on a river called the Paluxy River. A creation scientist named Carl Ball has spent 40 years looking at the footprints there. And he has actually, in the Glen Rose limestone, stratigraphically above the footprints, found a dinosaur fossil. I don't have the genus of that name memorized, but the point is there are rare places standing for truth that you do find stratigraphically above the footprints. And by stratigraphically above, I mean this way. The actual bones of the creature.
David, the analogy between the beach sand and the sandstone. I mean, the sandstone would have had a lot of minerals and cementing that would have happened. That's why it's in the state that we find it. So a footprint, say, in the sandstone at the Grand Canyon would be different to a footprint on the beach.
Well,
Because the beach,
can we get, by the way, Lena, thank you for that compliment. We will add you to the Christmas card list. But standing for truth, can you go back to that slide of the coconino sandstone that I had earlier?
Absolutely. Yeah.
And George, that will allow me to answer your question more specifically.
okay.
So we'll have to go back up. I think it's the third or fourth one in the PowerPoint presentation. So you got to go up, up, keep going. Oh, too far. Down one. One more. One more down. One more. Keep going. There. Whoa, whoa, whoa. Stop right there. Okay. Put your cursor on the very white coconino sandstone down from the rim of the, okay, yeah, right there. Recall that that sandstone layer is about 100 meters thick. But here's something that most people don't appreciate. That layer extends over much of the American Southwest. So this is a very extensive layer. Now, you have your cursor on the perfect place. The cursor that you have there is a knife edge contact with the units below.
Mm.
So, George, when I have walked by this and taken my students down the trail on the south rim cuts through the coconino, so you can actually get to a point where you see that contact. It's knife edge. And so I will turn to the students and we actually take our water bottles out and we pause for 5 minutes and we look at that and we say, if that was a real beach in the south of France, or that was a real beach in England, or a beach in Eastern Australia, wouldn't you see sand dunes? Wouldn't you see erosion? What's the answer, gentlemen? George, what's the answer to that? Of course you'd see erosion, right?
Yeah, well, there's no erosion there at all in none of the layers.
Exactly. And so that coconino sandstone is a remarkable example of the counter argument. The evolutionary community cannot sit there and tell me that a beach moved not just hundreds of miles, but thousands of miles, maintaining a what would you call it? A consistent thickness, and then have no evidence. If it's supposed to be an ancient beach, where are the sand dunes? Where's the erosion?
I have to say, Professor McQueen, too, for the last 30 minutes, your audio has been perfect. So I'm not sure if you did anything or changed anything, but it's been really.
It must be a bandwidth issue, like you've told me. So Matthew 10 here, the debunk, he says, don't we need quiet conditions for raindrops to fossilize? Well, there are raindrop imprints that I have seen in my field work in the southern Appalachian Mountains. Ordinarily, those fossil raindrop imprints that I have seen are in what in the southern Appalachian Mountains are called the it'll come to me here in a minute, the very prominent sandstone shale in the southern Appalachians. It's the equivalent to the it's equivalent to the tapetes. It's called the Rome Shale, R-O-M-E, Rome Shale. The Rome Shale occurs right above the great unconformity in the Appalachian Mountains. So it's an exact analogy to the tapetes in the Grand Canyon. What I find interesting is those raindrop impressions that I have seen must have been covered up very quickly after the beginning of the Great Flood. And so perhaps they were raindrops from Noah's flood itself as the rain fell. So that's one example that I would give as a counter argument that raindrops are always in still water.
David, I've got a question. I get this quite a bit in terms of the Grand Canyon. They say if there was a catastrophic event, why is it that we only see one Grand Canyon? Well, if you care to Google and search, there are literally hundreds of canyons. I was actually in Greece about 7 years ago, in the eastern part of Greece, and there was a sign there that said now I can't remember whether it was the longest or the deepest canyon in the world, and it was actually listed in the Guinness Book of Records. And I believe there's another one under the ice sheet in the Antarctic, which is probably bigger than the Grand Canyon. And
your point's well taken. By the way, Matthew 10 debunk there, I think I just explained that raindrop question. But let me go back to George's point here. Worldwide, there are at least 10 truly noteworthy canyons. The one in Greece that you described is obviously phenomenal in its length. In the Hawaiian Islands, there is a canyon there that a lot of tourists visit. I think it's on the island of Maui, if I recall. A very thick, not a very thick, a very deep canyon that's been cut through the volcanic rocks there of the Hawaiian Islands. And so it's true that you go over the world, but it's also true that the comment that Dr. Austin made at the beginning of our paper that we have on that slide is very well taken. Notice the first couple of sentences of the abstract. The Grand Canyon of Arizona is the best known example of hydraulic erosion on planet Earth. No other canyon on planet Earth has been so carefully scrutinized by geologists. So it is true, George, that there are others in Greece and other places. May I do a segue now to an aspect of the work that I did on this paper and the details? There you can see Ms. McQueen's head in the background there working on
Hello, Miss McQueen.
Christmas decorations. Let me go ahead and make a comment about another aspect of why I'm part of this paper. One aspect of it is my study of the canyon of the Mojave River, this 1/10 scale. But another part ties into the history of the development of this. And I began at the Institute for Creation Research in 1983. And I was there until 1987 when I left to get a degree in science education back here near my wife's hometown in Louisiana. And so I left in 1987 with the idea of going back in the early 90s. I was prevented from doing that because of the discrimination of the California State School Board. ICR at that point was in California, regarding the Institute for Creation Research being a young earth graduate school. At any rate, so I was there for those 4 years. And during those 4 years, I witnessed with my own eyes a number of graduate students with an interest in the Grand Canyon. I spoke with Dr. Steve Austin in 1983, and then he led a tour that I went on, a hike down into the Grand Canyon in the spring of 1984. And so his ideas about a breached, impounded river northeast of the Grand Canyon, I have heard for going on 40 years. Certainly 35 years, I have heard this argument being presented. And so when the graduate school was in full swing, Dr. Steve Austin had a number of graduate students that studied under him, as did I. And beside my office and in front of his office, there was a geology laboratory. And we had a vertical bulletin board. You can read more about this in the paper. But George, let me see if I can describe it to you. And then you can visualize it. Watch this, George. Imagine there being a vertical bulletin board. The vertical bulletin board had 10 different parts. And so instead of flipping it this way, you would flip it side to side. You get an idea of what this board looked like, George?
Yes. Sorry, I was reading a few things so I could ask you later on, but I didn't quite get your point there.
Well, it was a vertical bulletin board that we would meet and drink coffee at, and we would discuss things with the graduate students. For example, one of those boards, and you can imagine this being that board, vertical.
Yep.
One of those boards was the King and Bachman map of the geology of the United States. And we would talk about that to the graduate students. Well, on another one of these boards, there was a preliminary diagram that Ed allowed us to use in the mid-'80s to discuss the ideas of the Grand Canyon with our graduate students, the idea of spillover. And so we had discussions revolving around this. That bulletin board was kept in use after I left in 1987, and Dr. Austin used it to discuss things with students in the years to come. One of the things that I was glad to help with regarding my two professional friends, Dr. Steve and Dr. Ed, is to help them put a timeline on this issue of what we call priority of discovery, priority of an idea. The thing that we talked about 30 minutes ago, George, regarding Darwin and his grandfather Erasmus and so forth.
Mm-hmm.
So that's where I come into this. I hope you will read the paper online and fill in the blanks.
Oh, yeah, I've actually taken a note of it, and I'll be searching for it after this interview.
Okay, here's a standing for truth question. Biologos, our critics, say caves form in solid limestone. If the limestone was deposited rapidly and immediately buried by overlying sediments, as flood geologists say, how could caves form? Well, that's a wonderful question. Take a wild guess, Brother George, as to what my boyhood hobby was. Well, it turns out it was spelunking. Now, that's the name for amateur cave exploring. Do you know this word? Spelunking?
No, I don't. No, I don't. But I was going to guess at cave exploring.
Yeah, because I grew up in a part of East Tennessee that had numerous limestone caves. And so in my misspent youth as a teenager, I would go in and crawl into these places that were the diameter of my body. Now, the diameter of my body now is not what it was 55 years ago, but it was still spooky stuff crawling in this. So I've actually studied caves now for 55 years. And so with that background, I'll say this. The question for Biologos is naive. Okay, we get the red wall limestone precipitated during the flood directly from the seawater. It's buried over by all the other sediments, sandstones, shales, clastics. Then it's eroded, and we have established modern groundwater moving through that limestone. Beginning in 1989 and ending up in my retirement 5 years ago, I was a professional groundwater geologist studying the movement of groundwater through unconsolidated sediments and occasionally through limestones and so forth. So just like the old preachers used to say, put your hand on the TV screen and trust me. No, that's a little joke there. Just trust me, George, and standing for truth, that the movement of groundwater in the time of Abraham and in the time of the, what would you call it, the migration of the descendants of Shem, Ham, and Japheth to the area of the Grand Canyon, those hundreds of years are plenty of time to erode caves in the red wall limestone.
That's a great answer, Professor Mcqueen. I got to point something out too, because these top objections from Biologos and also these objections found in this book we've been talking about over the course of the last 30 minutes, Professor Mcqueen, you've just systematically debunked and dismantled them. So it kind of goes to show just how strong the evidence is for our position. And I just wanted to say God bless you and thank you for that. You're really helping out the audience here and helping us out here.
But let me put a disclaimer in here. Your words are very kind, but remember that I started a study of this creation evolution debate 55 years ago when my friend Jim Walker and I debated evolution in our high school biology class. We actually debated our high school biology teacher. And at times she didn't appreciate that at all. And the resources that we had, and I'm talking about 1966, 1967, the resources we had as teenagers consisted of one magazine article. The answers to the questions that are being asked, like Matthew 10 debunk here, nests of dinosaur eggs. There are tremendous resources now. I would recommend that you go to the Institute for Creation Research, ICR.org, and simply search under dinosaur eggs, and you'll find a discussion of this. But can I go ahead and take this question?
Yeah.
Absolutely. Go ahead.
Nests of dinosaur eggs are found in several places around the world. And it is illogical that dinosaurs could have had enough time to create and lay their eggs. Okay. Okay. How to answer that? Let's answer it this way. I'll again use the witch's head as the angular unconformity. We'll make this igneous rock from the time of creation. And we will use this well-kneaded Play-Doh here again as on top of it. Now, from a flood geology standpoint, how do we know, using the vocabulary that Tim Clary has introduced us to at ICR, this sequence stratigraphy? In other words, you don't use the word Cambrian, Ordovician, Silurian, Devonian. Use words like Salk sequence, Tippecanoe, Zuni, and all these different words that are used to describe sequence stratigraphy. Okay, so let's say that we go to a place in India that I know of where there are sediments on top of what I would call Creation Week rocks that contain dinosaur fossils. Now, of course, the evolutionists would say that we've got all this eroded material so that we go from 600 million years up to maybe 100 million years. So we got 500 million years of erosion. Well, see, as a flood geologist, we don't have to say that, do we? We can say that the dinosaur fossils are found buried the first 40 days and 40 nights of the rapid erosion of the first phase of the flood. And so these dinosaurs, Matthew 10 debunk, didn't have to walk around to the subcontinent of India to lay their eggs. They were laid and buried in that first 40 days of the flood. Does that make sense, gentlemen?
It does to me. David,
It does. It does.
Just to reinforce, when I was doing my engineering course, we actually studied groundwater movement specifically below dam walls, and the length, the actual depth of that dam wall, and how that water, the underground water movement, occurred below that dam wall.
Yeah.
So yeah, it's a very I guess if you're into dam design, you really need to know about groundwater movement.
Exactly. And let me make a follow-up point there. Many of the audience may have visited Washington, D.C., and you may be aware that many of the monuments there, the Jefferson Memorial, the Lincoln Memorial, the Washington Monument, some of these were made from limestones, blocks of limestones the size of a modern car were moved in there and formed the foundation. Well, park rangers, knowing when these were designed and built, have gone down underneath these monuments here in Washington, D.C., and have found stalactites and stalagmites. Now, you might remember from your earth science that stalactite and stalagmite are types of formations in a cave, either growing down from the top or up from the bottom.
Bottom, yeah.
And so people will go to some of the famous caves in America, like Carlsbad Caverns and places like that. And they'll say, oh, listen to us, Mr. and Mrs. Smith from the middle of America that have never studied geology before. We're going to tell you that these stalactites and stalagmites form over thousands, hundreds of thousands of years. Well, explain to me why that kind of structure can be found with a limestone monument on top of it, just from rainwater. You see the point, George, I hope.
Yes, I've had the same experience. I've been to the caves in Sheffield, Tasmania, and the tour guide there pretty much said the same thing, and I had to correct him because we see those formations under bridges, and in railway caves and whatever. So, and we see it in real time. We don't need millions of years to watch them grow.
Okay.